Hello, everyone. This is practice with limits going to infinity. Definitely something you'll see in AP Calculus, not just limit problems, but when we talk about horizontal asymptotes or the end behavior of a function, what we're really looking at is limits to infinity and to negative infinity. I think these 6 problems really will demonstrate most of the issues that you encounter when you do limits to infinity. 90% of the time, we're really looking at fractions and comparing the top of the fraction to the bottom of the fraction. Because if the top dominates, if it grows a lot faster than the bottom, then the function itself will go to infinity. If the bottom dominates, if the bottom function is growing faster than the top, then it's going to go to 0, because you'll have eventually you'll have a small number over a very large number. But if the degrees are the same, then we really want to compare the leading terms, and we'll get our answer from that. Okay. So for example, in this first problem, when we're at infinity, you only care about that term. 4x is insignificant. The minus 3 is insignificant. So what this really turns out to be is negative 5x cubed over 8x cubed. That's going to control what the value of this function is. And if the x cubes cancel out, we get negative 5/8. Okay, and we can do a similar problem here. This time, though, you have to realize that if we're in the square root, then the significant part of the top of the fraction will be square root of 5 times x to the 8th, and the bottom is 3x to the 8th, and we're left with root 5 over 3 if we cancel, right? And you could, if you wanted to use a calculator, you could put these functions in and plug in very large numbers, and eventually, it would look like this number if the calculator can handle it. I didn't mention the cosine of x. Why is that insignificant? Because cosine of x has to be between 1 and negative 1, so it really doesn't play a role when x is large. All right, and here I didn't focus in on the sign. I'm at infinity, so I'm not too worried, but it's best practice to always check the sign of the top and the bottom when x is very large. If you plug in a large x value, the top is definitely positive, and the bottom is definitely positive, so I do like the root 5 over 3. In contrast to that, though, a lot of people might, when you first do these problems, go through the process of figuring out what is significant. Here I have root 5 times x to the 7th, and on the bottom I have 3x to the 7th. And we're going to negative infinity, and you might think that these cancel out, and you're left with root 5 over 3. That would be a mistake if you circle that as your final answer, because the square root and the even exponents really messed with the signs. So if x is at negative infinity, or a very, infinitely small number, then the top is still positive, but odd exponent would make the bottom negative, and in fact the final answer would be negative root 5 over 3. All right, so we are talking about significant terms, and the question is, if the top dominates, then we're going out to infinity, or maybe negative infinity. If the bottom dominates, then we're going to 0. And the rule here is 2 to the x is an exponential function. As long as the base is bigger than 1, I could have had 1.01 to the x. The top will dominate eventually, right? If x is large enough, the top will dominate, and this is going to be positive and positive. This does come up to infinity, because eventually 2 to the x grows incredibly fast, much faster than any polynomial. Doesn't matter what the polynomial is, exponential functions will grow faster. So you might think, how about to negative infinity? You might think that the 12 is insignificant and the 3 are insignificant. But you do want to remember that we're going to negative infinity here. And if you think of what 3 to, let's just on the side figure out what, let's just do 3 to the negative 1,000. what is 3 to the negative 1,000? Well, that's 1 over 3 to the 1,000. And that is, 0.000. It's going to be a very tiny number. So in fact, at negative infinity, this is insignificant, this is insignificant. And what's left over will yield an answer of -4. Okay, so the long way to do this problem, because we are comparing the fractions, is to get a common denominator and FOIL this, or rearrange this until you do have a fraction over a fraction. But if we think of this as one big function, this plus 11 is really just a vertical translation of this fractional function. So we really can do our analysis on the first part here, and 3x times 3x times 3x is 27x cubed, and this is 8x cubed, and so we'll have, just as this part, 27/8. But if you realize that you could add, we'd want to add 11 to there, because this is really just moving the function up 11 units, which would move up the horizontal asymptote, and so our answer will be, I think what's the best way to deal with this? Let's make this 3 3/8 plus 11, we'll make that 14 3/8. You could have also gotten a common denominator there. All right, so there's some good practice problems down here. Best of luck practicing. Bye, everybody.